Within a unit circle, the radius is going to be 1, and this allows us to put in a bunch of different right triangles in order to look at the relationship of sine, cosine, and tangents. In a unit circle, we can let the values of the x-axis be equal to cosine theta. Similarly, the y-axis will be representative of sine theta, and the longer that cosine theta is, the shorter sine theta will be, and vice versa. In order to understand why the unit circle has coordinates, it is important to review the special right triangles. In a 30, 60, 90 triangle, the ratios of the legs to the hypotenuse are 1, root of 3, and 2. In a 45, 45, 90 triangle, these ratios are 1, 1, and root of 2. If you are trying to find the sine of 30, for example, you would look at the side opposite the angle and then the hypotenuse, so you would get the sine of 30 would be a half. Conversely, the cosine of 30 would be the adjacent side over the hypotenuse, or root 3 over 2. So let's say that we had a positive 30-degree angle in the unit circle that came up from the x-axis. We would see that this would have a coordinate of root 3 over 2, 1/2 on the unit circle. Again, this is because the cosine values are x values and the sine values are y values. And you can see that this is consistent with the other special right triangles as well. Here are some of the coordinates that I went over, and you can see how it repeats throughout this circle. If the angle is found within quadrant 1, or that upper rightmost corner of the unit circle, then the sine and cosine values will always be positive. However, if we look at quadrant 2, we can see that the sine values are now negative, while the cosine values remain positive. All the coordinates in quadrant 3 will be negative, whereas in quadrant 4, cosine will be negative and sine is positive. As another way to measure an angle, you can convert degrees to radians by multiplying by pi over 180.